Hi everyone, this is a Math OD2 video, and we're doing section 3.3, scientific notation. Specifically, this video is an example of how to divide numbers which are being written in scientific notation. So the way I'm looking at this is I'm kind of looking at it as two separate problems. I'm looking at this as just a plain old division problem, which I could probably do with a calculator. And then I'm looking at this also as a problem where I'm going to have to use one or more of the exponent properties that we learned. So if you just type in 4.96 over 3.1 into your calculator, you find that it's 1.6. Over here, remember we have to use the quotient rule. And if you need to review that, I made a video of it. So what we're going to be doing is we're subtracting our exponents. And again, it's always a good idea to write this out because as you can see, we have minus a negative, which becomes 4 plus 3, which is 7. A lot of times when students try to just do that really quickly in their heads, they accidentally subtract 4 and positive 3 and they get 1. So be careful of that. So that's it. This is your answer here. You have 1.6 times 10 to the 7th. So let's move on, since that was so short. Let's do a more challenging example here. So once again, the way I'm looking at this is I'm looking at it as two different problems. The first problem I'm looking at is this simple division problem, which again you can perform that with any sort of calculator. And then the second part of our equation is the one where we have to use the quotient rule. So the reason this is more challenging is when you type in 2.014 divided by 3.8 into your calculator, you get 0.53. And as previously stated in all my videos, that is not scientific notation. Okay, so we're going to have to do an extra step here in order to get our final answer. But let's keep going. So here we're using the quotient rule, which means that we subtract. We have negative 3 minus negative 7. Again, it's always a good idea to write this out because, as you can see, minus a negative becomes plus a positive. We have negative 3 plus 7. That gives us a positive 4. Okay, so I've said it in previous videos. I'll say it again. Most people want to stop here. This is not your final answer because by definition, this is not in scientific notation. Okay, the way scientific notation has to look, you can have as many numbers after the decimal point as you want to, but you can only have one digit there in front of your decimal point. Okay, so remember, just like we did in the last bit, okay, we're going to take this number and we're going to convert it to scientific notation. Okay, so let's see what we can do here. So we have the number 0.53. Okay, so our decimal point is starting here. Okay, and where does it need to end? Well, it needs to end so that I have just a single digit after the decimal point. So I really just need to move it over one space so that I have 5.3. Now, to complete my scientific notation, I'm going to have 10 to the something, right? And again, it's either going to be 10 to the first power or 10 to the negative first power. And honestly, most of the time, this is where students get a little bit derailed, okay? As you can see, we move the decimal place to the right. But in a previous video, I discussed why thinking about it in terms of left and right, positive and negative, is kind of an effort in futility because it also depends on whether you're going from standard to scientific or scientific to standard. And oh, by the way, it's the opposite for each one. So, to me, a more robust way of thinking is just to simply ask yourself, okay, 0.53, is that less than 1 or is it greater than 1? Which one is true? right? And if you think of it in terms of money, 53 cents is less than $1. So this is less than 1. And in the video that I made previously, we learned that if you have a number, any number that's less than 1, then when you're writing it in scientific notation, you have to use a negative exponent. So therefore, we can conclude that 0.53 becomes 5.3 times 10 to the negative first power. Okay, and if you want, you can go backwards and redo it and prove to yourself that that's the case. So let's see if we can figure out what we just did. We had 0.53 times 10 to the 4th power. We rewrote this bit as 5.3 times 10 to the negative first power, but this 10 to the 4th guy, he's still out there. He's still just kind of hanging out, doing his thing. So now, hopefully you can see that I can use the product rule right here. And the product rule tells me to simply add my exponents. And when I do that, I get the answer 5.3 times 10 to the 3rd.